Let's look at more examples on differentiation of logarithm functions. Now, before we continue, let's take a quick review on the laws of logarithm. Okay, and there are three basic laws of logarithm. That says log a multiplied by b is equal to log a plus log b. Log a divided by b is equals to log b log a minus log b, and log a raised to power n is equals to n log a. Now, instead of using logarithm, let's now use natural logarithm. That's logarithm to base e. Okay, so we can, instead of using logarithm, we change it to logarithm to base e, and our a will now turn to, let's assume our a becomes f of x and our b becomes g of x. Therefore, we're saying that lane f of x multiplied by g of x is equals to lane f of x plus lane g of x. Secondly, lane f of x divided by g of x is to give us natural logarithm of f of x minus natural logarithm of g of x. And finally, lane f of x raised to power n give us n natural logarithm of f of x. Now, with this being done, let's look at an illustration. Given that y is equal to f of x multiplied by g of x divided by h of x. We are given this format, and then we are asked to differentiate such a function. Of course, we can go ahead and use a quotient tool and product tool. Well, let's take that we are asked to differentiate it using logarithm differentiation. The first thing to do is to take natural logarithm of both sides. Okay, so that we have lane y is equals to lane into f of x into g of x divided by h of x. Now, applying the principle that we have learnt in the previous page, that when it is multiplying, it becomes addition, and when it is dividing, it becomes subtraction. Therefore, this becomes lane f of x plus lane g of x minus lane h of x. We can see that f of x and g of x are multiplying. That's why there's an addition sign, and h of x is dividing. That is why we have a subtraction sign. Now, there is a principle to solve further into logarithm differentiation. It states that d dx of lane y is equals to 1 over y dy dx. This is very vital. Now, let's take an example. Given y is equals to x plus 1, x minus 2 raised to power 3 divided by x minus 3. And we are asked to use logarithm differentiation to differentiate this function. Now, the first step to do is to take natural logarithm of both sides. take ln of both sides. So we have ln y is equals to natural logarithm of x plus 1 x minus 2 cube divided by x minus 3. Now let's apply what we have here and we apply it to this. So we can say ln y is equals to ln into x plus 1 plus ln into x minus 2 cube minus ln into x minus 3. And thereafter, this up can be further simplified using the third law of logarithm as ln into x plus 1 plus 3 ln into x minus 2 minus ln into x minus 3. Now, having this now, we can now differentiate both sides with respect to x. Differentiate both sides with respect to x. So we have dx of ln y is dx of everything here. So we can split it to have ddx of ln into x plus 1 plus 3 ddx of ln x minus 2 minus dx of natural logarithm of x minus 3. Now, if you go back to what principle we had here, ddx of natural logarithm of y is 1 over y dy dx. So this will give us 1 over y dy dx. And in our previous video, we talked about how to differentiate natural logarithm of a function such that we have ddx of natural logarithm of f of x is equal to f prime of x divided by f of x. So we take the f prime of this and differentiating x plus 1, we have 1 divided by x plus 1. Differentiating x minus 2, we have 1 divided by x minus 2. Differentiating x minus 3, we have 1 divided by x minus 3. So therefore we have 1 over y dy dx is equal to this principle was treated in the last video. So if you skipped it, kindly go back and lay emphasis on it. And this will be 1 over x plus 1 plus 3 divided by x minus 2 minus 1 over x minus 3. Therefore, let's multiply both sides by y so that we'll be left with dy dx here. So this will be y multiplied by 1 over x plus 1 plus 3 over x minus 2 minus 1 over x minus 3. So substituting our y back into the equation, and we know that our y is this question. So this will give us x plus 1 x minus 2 cube divided by x minus 3. Everything multiplied by 1 over x plus 1 plus 3 over x minus 2 minus 1 over x minus 3. Let's take another example on differentiation. on logarithm functions. 2. Given y is equals to x raised to power 3 ln 2x divided by exponential x sine x. Now, as usual, the first step to do is to take natural logarithm of both sides. Therefore, ln y is ln of x cubed ln 2x divided by exponential x sine x. Then let's split it applying the laws of logarithm. So this will give us ln x raised to power 3 plus natural logarithm of ln 2x plus ln exponential x plus natural logarithm of sine x. Now we can see here that natural logarithm and exponential function will nullify each other. However, this is not the same here. So we have that ln y, natural logarithm of y, is ln x raised to power 3. And likewise, we can also split further x raised to power 3 applying the third law of logarithm to give us 3 ln x plus ln of ln 2x plus x plus ln sine x. Now with this done, we take differentiation of both sides with respect to x. And when we differentiate ln y, we recall that differentiating with respect to x of ln y will give us 1 over y dy dx. So this is 1 over y dy dx is equal to d dx of 3 ln x plus d dx of ln 2x plus d dx of x plus d dx of ln sine x. Therefore, we now have that 1 over y dy dx. This will give us 3 over x plus, remember that this is like a function of a function. So when we differentiate it, we'll have 1 over x divided by ln 2x. Okay, we missed it somewhere. We should be having minus here, not positive, because they are dividing. Minus 1, and this will give us cos x divided by sine x. Therefore, 1 over y dy dx is equal to 3 over x plus 1 over x in 2x minus 1 minus cos x. Therefore, the y dx is y multiplied by 3 over x plus 1 over x then 2x minus 1 minus cos x. The y dx therefore is equals to x raised to power 3 and 2x e raised to power x sine x multiplied by 3 over x plus 1 over x then 2x minus 1 minus cot x. Let's take a final example on this topic. We're given the function that y is equal to square root of x raised to power 3 x minus 2 raised to power 3 divided by x plus 1 squared and 2x minus 1. We're asked to differentiate this with respect to x. Now let's rewrite this function well. So we have this to give us x minus 3, x minus 2, applying the law of indices. It will give us 3 over 2 divided by x plus 1 squared and 2x minus 1. Now the first step to do is to take natural logarithm of both sides. So we have ln y is equals to natural logarithm of x minus 2 is power 3 over 2 divided by x plus 1 all squared and 2x minus 1. So now let's apply the laws of logarithm to split this into a straight line. So this will give us ln x minus 2 3 over 2, because that's in the numerator, and in the denominator we have ln x plus 1 squared minus ln 2x minus 1. Now let's apply the third law of logarithm to simplify the powers. So we have ln y is equals to 3 over 2 ln x minus 2 minus 2 ln x plus 1 minus ln into 2x minus 1. Now with this down, we can now differentiate both sides. Differentiating ln y, we have 1 over y dy dx, and differentiating 3 over 2, we have d dx of ln x minus 2 minus 2 multiplied by d dx of ln x plus 1 minus d dx of ln 2x minus 1. And we recall that whenever we are differentiating d dx of natural logarithm of f of x, we will be having f prime of x divided by f of x. Henceforth, we have dy dx. This will give us 3 over 2 multiplied by 1 over x minus 2 minus 2 multiplied by 1 over x plus 1 minus differentiating 2x minus 1 will now give us 2 divided by 2x minus 1. So therefore our 1 over y dy dx is 3 over 2 into x minus 2 minus 2 into x plus 1 minus 2 into 2x minus 1. So let's multiply both sides by y. The y dx therefore is equals to y multiplied by 3 over 2 into x minus 2 minus 2 into x divided by x plus 1 minus 2 again divided by 2x minus 1. So therefore we now have to substitute our value of y, and y from the question is this. So substituting our value of y back, we have that the y dx is equal to square root of x minus 2 raised to power 3 all divided by x plus 1 squared and 2x minus 1. Is all multiplying 3 into 2 x minus 2 minus 2 into x plus 1 minus 2 into 2x minus 1. Therefore, let's take a quick recap on this form of differentiation with logarithm functions. We recall that when we want to differentiate with respect to x of natural logarithm of f of x, final answer will be f prime of x divided by f of x. Also, when we differentiate with respect to x of lane y, we have 1 over y dy dx. And also, we remember to apply the laws of logarithm. That says log AB is equal to log A plus log B. Log A over B is equal to log A minus log B, and log A raised to power n is equals to n log A. So in our next video, we'll be talking on partial derivatives, and from there we'll move into first order partial derivative, second order partial derivatives, and even total differential.